As we gaze upon these images, we realize that every second at the core of the Sun, 700 million tons of hydrogen are converted into 695 million tons of helium due to nuclear fusion. The remaining 5 million tons of matter are released as energy, thus generating the 27 million degrees Fahrenheit temperature that exists in its core, a core that is nearly as dense as lead. The Sun is a star that constitutes the largest source of electromagnetic radiation in our planetary system. It is more massive than the average stars in the universe, with almost 90% of them having less mass and being mostly colder and dimmer than our Sun. The surface of the Sun presents us with an astonishing and extraterrestrial landscape. It is a place where violent eruptions throw tons of electrically charged particles into space at speeds of more than 620,000 miles per hour. The Sun is a changing and almost perfect sphere of plasma, teeming with sunspots. These sunspots form immense regions with lower temperatures and intense magnetic activity and can reach up to 7,500 miles in diameter, which is practically the same size as our planet. Sunspots appear, grow, change their shape and dimensions, and finally disappear after existing for only 1 or 2 solar rotations. Sunspots may appear dark on the surface of the Sun, but if they were located in space, they would shine 10 times brighter than the full moon on a clear night. We know that the first rigorous observations of these sunspots were made by Chinese astronomers around the year 28 BC, although mentions of them have been found almost 4 centuries earlier. These astronomers lacked the precise instruments that we have today, but even so, they probably could appreciate these sunspots with the naked eye when the intense light of the Sun was filtered by the dust dragged by the wind from the deserts of Central Asia. Like on Earth, earthquakes also occur on this celestial body. In 1998, scientists recorded one with a magnitude of 11.3 on the Richter scale. By contrast, the most intense earthquake ever recorded on Earth has been 9.5. These earthquakes produce immense plasma waves up to 1.86 miles high, which can move at incredible speeds of 250,000 miles per hour. Some have even been detected at speeds of more than double this speed. The Sun is a gigantic celestial body with a diameter 109 times greater than that of the Earth. Its sphere could fit 1.3 million Earths. Despite being approximately 93 million miles away from us, it can severely affect us with its coronal mass ejections. These ejections are made up of plasma consisting mainly of electrons and protons, and may contain small amounts of heavier particles, such as helium, oxygen, or even iron. This wave of radiation and solar wind can damage electrical circuits, transformers, and communication systems, in addition to sporadically reducing the Earth's magnetic field. This reminds us that we always live at its mercy. The Sun is a Type G main sequence star that is often referred to as a yellow dwarf, although this is a misnomer. The color of the Sun's surface is actually white, not yellow. This color is best observed from space, which prevents the Earth's atmosphere from altering its color to yellow, orange, or red, depending on the position of the Sun relative to the observer's location on Earth. This effect, known as Rayleigh scattering, is the result of the electrical polarization of particles and also causes us to see the sky as a blue color on clear days. Throughout history, the Sun has been revered as a god by many civilizations, from the ancient Egyptians, who worshipped it under the name of Ra and later Aton, to the Mesopotamian civilization, which knew it as Atu. The Inca worshipped it under the name of Inti, and the Aztecs knew it as Tonatiuh. Many others, such as ancient China, Japan, and Greece, the cradle of Western civilization, also revered the Sun. For example, in Greece it was known as Helios. Upon careful consideration, the Sun reveals itself as a true God from our perspective, capable of engendering life or ending it, of creating or destroying with its almost infinite power. It is a colossal nuclear reactor that is responsible for the water and carbon cycles on our planet, as well as the nutrient cycle, supporting the base of the food chain through photosynthesis. Practically every being that lives on Earth depends on the Sun in one way or another. The Sun is a gigantic celestial body that lacks consciousness, contrary to what ancient human civilizations that worshipped it might have believed. However, that does not prevent it from being capricious in its own way. It can also be prophetic and augur the day of final judgment for our planet. Scientists estimate that in about 5 billion years it will become a red giant, and its diameter could reach and surpass that of Earth's orbit. This would end life on our planet forever, turning this blue paradise full of life into a barren and sterile rock. In this image, you can get an idea of the difference between the current diameter of the Sun and its maximum estimated diameter during its red giant phase. The Sun, a star that rules our lives, makes up 99.86% of the mass of the solar system. The 8 planets we know, including the immense gas giants like Jupiter and Saturn, in addition to the more than 170 known moons, the asteroid belt, the distant and icy objects of the Kuiper belt, and the millions of comets that roam space under the gravitational influence of the Sun, all add up to just 0.14% of the mass of our solar system. These data clarify why our host star is the king of the solar system. It is an immense mass made up of 71% hydrogen, 27% helium, and a remaining 2% of multiple heavier elements. The Sun, like all other stars in the universe, is composed of the remnants of ancient stars that perished billions of years ago. It orbits around the center of the Milky Way, completing an orbit every 230 million years, traveling at 514,000 miles per hour, and taking us along on its incredible odyssey. Eventually, the Sun will become a white dwarf when it has exhausted its nuclear fuel. This stage of stellar evolution is one that 97% of stars go through, and along with red dwarfs, white dwarfs make up the most abundant stars in the universe. A white dwarf is a type of star that no longer produces thermonuclear reactions and is primarily composed of carbon and oxygen. Newly formed white dwarfs have very high temperatures, but as they do not produce energy, they cool down over tens or hundreds of billions of years until they become black dwarfs, ceasing to emit energy forever. However, scientists believe that the cooling process of a white dwarf is so slow that the age of the universe itself, about 13 billion years, is insufficient to harbor any of these black dwarfs. And that's where our video for today from Via Doctus ends. If you liked the video, don't forget to give it a like and subscribe to the channel. Thank you very much for watching the video. See you in the next one.